Hi guys, you're welcome to our Git class. So this is going to be our first class on DevOps fundamentals, and here in this particular video we are going to be learning how to use Git to automate our processes. Now, what is Git? Git is a version control tool. We use it to track changes made in our applications. Git also enables us to work remotely and connect with other developers or other team members. Git also helps us to connect with other team members so that we can work together as a team. Now imagine having an application that is already in production and people are already using this application, and you want to make a change into this application. Most times, without DevOps or Git, what you would basically do is either to go to your through file transfer protocol, that's FTP, or you go to upload. You have to zip the file, upload it, and then unzip. So sometimes maybe if people are actively using it the same time that you want to do this update, you will notice that so many things are going to break out. There could be some dependency issues and other problems that may emanate from that place. But when you use Git enables you to be able to test out that this application works or the update works properly before you push to production. So Git is a very essential tool that every developer and software engineer must have. Let us start with Git. So Git works with what we call the repositories. So a repository is where your source code lives. It's just like a house that houses your source code. Repositories, we have two types of repositories. We have the local repository and we have the remote repository or the origin repository. So the remote repository or the origin repository is the repository online, whereas the local repository is the repository within your own computer. So if I initialize any Git repository within here, it is going to be a local repository because it is only found within my local system. It is not found any other place in the world. So a local repository lives locally on your own computer, whereas a remote or origin repository lives online in another computer. And an example of an origin repository or a remote repository is GitHub, Bitbucket, GitLab, and so on. These are what we can classify as origin repositories. Now, Git is different from GitHub because most times so many people will think that Git is the same thing as GitHub, but they are actually two different things. Git is a version control tool, whereas GitHub is a cloud storage for storing your repositories. So when you want to store your repository on the cloud, you use GitHub. There are so many other examples like GitLab, Bitbucket, and so on. These are other cloud storage that you can use to store your repository on the remote origin. So remote origin is the same as a repository that is hosted online in the cloud, whereas local repository is the one on your system. So let's initialize a local repository right here. So I am going to bring up my terminal with Ctrl J. So here I'm going to select Git Bash. So I'm going to use Git Bash. Now in this video I am not going to be showing you how to install Git Bash, but if you want to install Git Bash, just go to your browser and type Git Bash. First website that you will see there is their official website. Click there and download and then install on your various operating systems. It's very easy to install. Once you are done installing Git Bash, you can be able to use the bash directly inside your Visual Studio Code. So right here I am going to do Git init. So Git init is used to initialize a Git repository. Before this Git init, if I do ls-a and press enter, you would see the only files I have here is dot and dot dot, which are the configuration of this project. So but if I do Git init, press enter, this is going to initialize an empty repository, as you can see here. And if I do ls-a right now, you would see it created a .git folder. And this .git is where my Git lives. So right now, Git can be able to track all changes that is made within this project. So let's try creating a file, readme.md. So we have created a file called readme.md, and if you look at here, you would notice that this indicates that Git has not tracked this particular file. So Git is not tracking this file. So what should we do to make sure that Git is tracking this file? So to make sure that Git is tracking this file, we can simply come back to our bash and use git add, followed by the name of the file, which is readme.md. Press enter and Git is now tracking it. You can see it has changed to A, which means it has been added to Git. And the next command I am going to be showing you is the Git status. So the Git status is used to check the status of your Git history. So you can do Git space status, press enter, and you can see the status of this file changes to be committed. So I have a new file, but it has not been yet committed into the Git. But it has been added to the list of files that is being tracked by Git. Let me create one more file. Let me create readme.md. This time around, capital letter. The file already exists in this location. Okay, let's make it index.html. Now let's try Git status again. Notice something. Git is tracking this, but Git is not tracking this, and this is because we added this to Git using git add, but we haven't done that to this one. And if we don't do that, git add, index.html. Enter and do git status again. Notice Git is tracking it right now, but there is no commit yet. So git commit does not exist here, so we have not committed any file on Git already. The next thing I'll be showing you is how the remote origin can communicate to the local repository, because right now all this file is recorded in the local Git, which means the repository we have here is a local repository. But we can actually create a remote repository on GitHub. So the first thing first is for you to go to github.com and create an account. Once you've created an account, come and create a repository. If you click here, you will see new repository. Click on new repository. And this is going to take you to where you would create a repository. I'm going to call this repository DevOps class. And you can see here, this repository is okay. And then don't add anything here. So here is the visibility of your repository. So if you leave it at public, and anybody around the world can actually visit your GitHub account profile, and they can go to your repositories and see the code to your project. But if you use private, then the repository will only be private to you, to other people except you. So you'll be able to access this repository, but other people cannot access this repository. So for learning purpose, I'm going to leave this repository as public. And then leave everything the way they are and create repository. Now this repository has been created to connect the local repository with the remote repository that we just created. So here we created a remote repository called DevOps class, and right inside our code we have a local repository created here, but we want the two of them to communicate and share data. So in that case, we can actually come here and copy this particular code, Ctrl C. So since we have copied this code, we can paste it here and press enter. Now this repository, the two repositories now have been working together. The upstream repository, or the remote repository, which is the origin repository, and the local repository are now communicating to each other. Again, is that you can use this to set up the branch as main. So for here, I already have the branch as main, so I'm not going to do that. But here we have git push -u origin main. So this is where we can push to our Git. But before we can do this, we need to tell Git who is actually doing all this, who is committing, who is adding these files, who is transmitting these files. Because since you are working remotely, if you are working remotely with a team and a lot of changes are made in an application, how do you now track who made a certain change in a certain file? So in that case, that's where the git config comes in. So we use, let me clear this. So we are going to use git config dash dash global. So the global is to make sure that whatever configuration that I set here is also applicable to both my local repository and my remote origin repository. So git config dash dash global user dot name, and then I'll set up my username, which is varsity1. You should know your username. So my username is varsity1. Enter. Do the same thing, git config dash dash global user dot email. I will use VGS ICT Hub at gmail.com. And now Git knows who is making these changes. The next thing is to commit our changes. Now for the git config, it's only once in the project, so that you would tell Git who is committing, who is doing these changes. In other ways, you don't do it again. It is just once in a project. So right here, I'm going to use git commit -m. So the -m represents commit message. A commit message should be imperative and simple. Now, commit message should answer this question. After this commit, or when these changes is pushed online, these changes is going to do dash. So it's going to do what? Then you answer what this project is, these changes is going to do. For example, this project is going to do dash. So I can say add red color, change background. Okay, just imperative, very simple and on point. So let's say initial commit. So let me know that this is my first commit actually. So press enter and it has been committed. You can now see that all the changes that are being untracked here has gone. Right now, let us push this content into the one on the GitHub, because right now the one on the GitHub has nothing inside it. It is empty repository. So we can now copy what we have here, git push -u origin main. And this has been pushed to our remote origin repository, which is the one on the GitHub. Let's check by refreshing our GitHub. You would notice the two files on our local repository, which is these two files, are here on our remote origin repository. Now, for the first time you are doing this, it's going to prompt you to give it access to your GitHub account. So you can do that, and once you do that, it will be added. And you can see my commit message here, initial commit. Let's clear this. Let's repeat this. Let's make some changes into our application. I'm going to hide the terminal and add a markdown. This is a test class for Git and DevOps fundamentals. this video, or this is for my YouTube video for the study class. All right, so I've made a change. Notice something, there is a line here and it says changed line, and this is where all the changes, whenever you make a change, it detects where the change is and shows you where you made that change. So it's easier for you to track your changes, and the best way to handle Git is to make sure that any change you do, you commit immediately. Don't wait until you are done to commit. You commit. So I'm going to do git add dash to commit all, to add all, and then git commit dash m, and I'll say added readme content. Enter. So I have committed these changes. You can now notice it no longer shows here. If I should add any other changes right below here, you would notice the green line that shows that I am adding a new line. Okay, let's add into the HTML, and let's say DevOps. Let's add header and say h1 DevOps. And now we have made a lot of changes, as you can see here, and we can commit as well. Git add dots, and then git commit dash m added HTML content. And I've added this file. Now we can actually push direct to the remote origin by using git push. So git push is going to push the contents on and all the changes that we have made, making sure that the remote repository and the local repository are of the same status. So if I do git status here, you can see on branch main, your branch is up to date with the origin main. Nothing to commit, working tree is clean. And if you go back to your GitHub and refresh, you would notice the second commit will appear, like you can see here. This is the second commit, added readme content, added HTML content. And you can see this particular one was made 2 minutes ago, while this was made 1 minute ago. This is very simple and straightforward. Okay, this is very simple and straightforward, and you can see we only have one branch, which is main branch right here. If we have other branches, they would show here. So the next command I'll be showing you is the git log. So the git log is used to show the history, should I call it history, of our Git. Who made what changes, when they made it, and so on. So look at here, you can see the first commit we did, the author is Varsity1, the email is this, date when the commit was made, and the commit, you can see, added HTML content. The next commit is added readme content, and this one, which is initial commit. So we have initial commits and so on. So let's take, for example, here I have this this HTML, and this is what I have online, and people are using it. And maybe we have a problem with this new update, and I want to revert back to the previous version that I have. Revert back to the previous version while I make the changes on the new version that brought out that error. So in that case, what we would use is the git log, and we are going to copy this commit header. So let's say the mistake was made on the HTML content commit, and these other ones are correct. So I'm just going to copy the head. So this is the head. I'm going to copy the head with Ctrl C, and then once I copy this head, I'm going to do git checkout, and then I'll paste this commit head. Press enter, and this is going to switch to the previous version before the error was made. And if you go back to this, you will see that the HTML now is empty, whereas this still contains its content. So this is why you should always commit. Once you make a change, commit. Don't wait until you are done with the entire project before you commit. You commit once you are done with a simple change. Once a single change, you commit. A single change, you commit. By doing so, you can be able to track all changes that you have made, which place the error came from, and then you can revert back. And once you change and update the code, there's no error again, you can push again. Now you can now see that my HTML is gone. My HTML is gone. But do you think this would also happen in the remote origin? Let us check. Let's refresh. Let's go to the index.html. It didn't quite happen. It didn't happen in the remote. So how do we make sure that this happens? Should we push? Should we do git push to make these changes to show here? Or is there any other thing that we could do? Now let's attempt the git push. Now we will notice something. It says fatal. You are not currently on a branch. Because actually, if you look at here, you can see that I am not currently on that branch, the main branch, actually. So I need to be on a branch to be able to do this. What if I want to undo this thing? What if I want to undo this and move back to where I was? To undo this, we use git switch and then dash. The reason I am using dash is that I only have one branch of repository there. So I'm pressing enter, and this is going to switch head to my main. As you can see here, I am now currently on the main branch. And right now you can see previous head position was this, and added readme content switched to main branch. So this has been switched to the branch, and the branch is up to date. So even if you do git push, it is not going to do anything because it is up to date. Look at it. You can see everything is up to date.